Hey, Mr. Say here. Today we're going to be talking about ratios and proportions. Let's just jump straight into it. So you're walking in a supermarket and you're looking for peanut butter, and you see that there are plethora of options on the shelf, and you notice there's three that you kind of fancy. Um, let's look at this scenario. So you have three sizes of this peanut butter that you want to buy. There's an 18-ounce jar that's worth $1.78, a 20-ounce jar worth $2.97, and a 40-ounce jar which is $3.98. I don't know why anybody would need 40 ounces of peanut butter, but nonetheless, let's go ahead and look at it. You are a frugal spender, and you don't want to spend too much for your peanut butter because your PB&Js, you like to put a lot of peanut butter, so you like to kind of go cheap on the peanut butter. So you want the best buy here, okay? So how could you decide what is the best buy out of these three peanut butter selections or three options you have here? And the answer is you need to use this thing called ratios to solve your answer, all right? The way we do that is by making little mini fractions, okay? And what you're going to do here is you're going to look at these three options and put them all in terms of the same unit, okay? Right now they're all like the prices is not comparable because they're all different sizes. However, if we were to put them all into the same unit, meaning what is the price for the first peanut butter per ounce, what is the second price of the second peanut butter per ounce, if we put them all in the same unit, it would be an easier decision to make, okay? So how do we do that? First of all, I'm going to add another column to this, and I'm going to say I want to find out what is the price per ounce, okay? So what is the price per ounce, okay? That per is another fancy way of saying dividing, okay? So if we took the price $1.78 and we divided it by 18 ounces, what we have done there is pretty much found out what is the dollar amount per ounce for that first size of peanut butter, okay? So let's go ahead and do that on our calculator. What is $1.78 divided by 18? And that will give us our price per ounce. That is showing me that that is 9 cents. Okay, so I'm just going to go ahead and write here, whoopsies, the dollar amount, which is 0.0. Let's round up to, no, we'll just leave it as 0.09, okay? So that is the price per ounce of that first jar. Let's do the same thing. Let's take the dollar amount, $2.97, and let's divide that by 28, and that's going to give us the price per ounce for the second one. That second one is, without rounding, is 10 cents. Okay, and then the last one we have there, which is $3.98. We're going to divide that by 40 ounces to get what its price per ounce is, and that's again going to be 0.09. All right. Now, it looks like we have a tie between the 18-ouncer and the 40-ouncer. Let's go to the calculator real quick to break the tie. All right, so if we look up here, the first one is 0.09888, and the other one is 0.0995, okay? Putting our thinking caps on, which of those is the smaller number? And you guessed it, the first option is the best buy, okay? So by looking at the calculator, knowing that that's just slightly cheaper, our 18-ounce option would be the best value for the price of peanut butter per ounce, okay? So that's a ratio, okay? It's just a fraction that's used to kind of get things into the same, for example, in this case, the same unit so that you can compare one thing to the next, okay? That's ratios. The next thing I want to talk about are proportions, okay? Proportions are where you take two ratios and set them equal to each other and use the ratios to help solve missing things or help solve for unknowns. For example, if you have the ratio 5/9 and you want to keep that ratio, but you have different numbers over here on the right, 63, I want to know, for example, well, what would this number be to keep that same ratio? And if I don't know what that is, that's usually when I go ahead and drop a variable, all right? So to do this problem, what math teachers have probably told you in the past is to cross multiply. And to cross multiply, you're going to take the numerator of the left one and multiply it with the denominator on the right one, and do the same thing, except this time we're going to multiply the denominator on the left one and multiply it with the numerator on the right side, okay? By doing that, you're going to have 5 times 63 and 9 times x. Between these two multiplication problems, I like to just drop the equal sign to keep it in the middle, okay? 5 times 63, we can go ahead and do that on our calculator, is 315. Looks like I lost the part of my 3 there, equals 9x. Okay, so 315 equals 9x. Using our knowledge of how to solve for linear equations, we can go ahead and divide each side by 9, and we have 315 divided by 9. On my calculator, when I punch that in, I get 35. Okay, so x equals 35 is going to be our answer. So if I were to plug in 35 up top here over 63, that would reduce down back to this 5/9, okay? Kept the same ratio, okay? Now, when can I use cross multiplication and when can I not? The only time you can use cross multiplication is when you have a fraction equal to another fraction. If you have a fraction plus another fraction or a fraction times another fraction, you cannot use cross multiplication any longer, okay? So cross multiplication for the most part is only used when we have a ratio or a fraction equals to another ratio or a fraction, okay? Let's look at one more example. This time we're going to look at a word problem because this is where proportions really come through very handy like. So here's the problem. We got, after Leanne Smith, the best name in the world, had pumped 5 gallons of gasoline, the display showed the price read $16.60. When she finished pumping the gasoline, the price display read $48.14. How many gallons did she pump? Well, she should probably look on the display that says how many gallons she pumped. But she's making it hard on us, so let's figure it out. So first of all, we have to start by writing down a ratio, okay? We know this is a ratio problem because you're being compared gallons of gasoline to a dollar amount, and then again, we have a dollar amount with a missing gallons of gasoline, okay? So you have 2 units right here, and you have another 2 units, okay? And they're being the same or being compared to each other, okay? So that's kind of how you know this is a proportions problem, all right? So first of all, I'm going to set up my first ratio, okay? I'm going to say that when that was $1.1660, there was 5 gallons displayed on the display, okay? And the other ratio I'm going to have is $48.14. I do not know how many gallons of gasoline there was. Okay, so that's something I am going to have to solve for. And to do proportions, just like in the problem before, we're going to put an equal sign in the middle. Okay, now here's the deal. You can do this however you'd like. You could put the gasoline on top and the dollar on the bottom. However, whatever you pick for your left ratio, where you have both of the numbers on the top and bottom, you have to mimic that for the other ratio. Notice how I put the dollar amount on the top and the gallons of gas on the bottom. You cannot switch them from one ratio to the next. That will mess up your problem, okay? Now, just like before, I am going to cross multiply. And that's going to help me solve for this, okay? So I got 1660 times x, okay? So I'm going to write 1660x equals 5 gallons times 4814, okay? So let's go ahead and do that on the calculator because I cannot do that in my head. 48.14, enter, okay? Which is $240.70. So let's go ahead and write that. 240.7. All right, now solving, we're going to divide each side by 16.6 or 16.60, depending on what you want to do. You really don't have to use that 0 if you don't want to. And that's going to solve for how many gallons we actually pumped at the end of our pumping session. All right, so let's go ahead and do that. 240.7, and we're going to divide that by 16.6. 6, okay? And the answer to our problem is 14.5, and that's going to be in gallons of gas, okay? So that's how we can go ahead and use proportions to solve real-life problems. We talked about today what a ratio is, how ratios can be used to kind of figure out what's the best buy. We talked a little bit about proportions and how to solve proportions using cross multiplication. And then we looked at a word problem, kind of how to set that word problem up, how to make sure that your ratios are equal to each other correctly, how to cross multiply, and then again solve for real life problems. Okay, hopefully that helped you out. Try a couple problems on that, and if you have any questions, call me on over. All right, thanks. Have a good day. Goodbye.